Hey there and welcome. We're literally surrounded by incredible technology every single day, but how much do we really get what's happening inside the box? Well, today, we're going to tear down the modern computer piece by piece, from the physical plugs you use every day to the invisible code that makes it all spring to life.
You've been there, right? You're shopping for a new laptop or a PC, and you see an ad that looks just like this. It's just this wall of text, full of acronyms and numbers that honestly feels like it's written in another language. It's supposed to get you excited, but it doesn't really help you understand what you're buying. For most of us, the answer is a big, fat no.
So yeah, what does all that stuff actually mean? That is the big question we are going to tackle right now. And I promise by the end of this, you'll be able to look at an ad like that and it won't be intimidating at all. You'll actually get the story it's trying to tell.
Okay, so here's the game plan. First, we're going to decode some of that jargon. Then, we'll look at the ports, how we plug things in. After that, we'll zoom out and talk about networks. Then, dive into what I like to call the ghost in the machine, the software. And we'll wrap it all up by taking a look at your digital toolkit.
So, let's start our journey from the outside and work our way in. Because really, to get what a computer does, you first have to understand how it talks to the rest of the world. And that journey begins with the parts you can actually see and touch.
All right, first up, computer ports. I want you to think of these as the gateways to your digital world. They're like the doors and windows of your computer. They're the physical spots where information and power flow in and out, connecting you to your mouse, your monitor, your printer, you name it.
So, at its most basic level, a port is just a physical connection point. It's a standardized hole that lets your computer connect with all sorts of other gadgets. I mean, without ports, your computer would just be a completely useless, isolated box, right? It couldn't do anything. Now, back in the day, there were mainly two kinds of ports. You had serial ports, which sent data one little piece at a time, kind of like people lining up and going through a turnstile one by one. Then you had parallel ports, which were way wider. They sent a bunch of data all at once, more like 8 people walking through a giant gate side by side. It worked, but man, was it a confusing system.
And then, everything changed. USB arrived on the scene, and this was an absolute revolution. The whole point was to replace that entire messy collection of different ports with just one universal standard. So what made USB such a game changer? Well, it was smart. It wasn't just a dumb pipe for information. It was built to be self-configuring. And that is the magic behind what we call plug and play. You plug something in, and the computer can basically ask, hey, who are you and what do you do? And the device can answer back. No more messing around in settings. It just works. Okay, so ports let us hook stuff up to one computer. That's cool. But what about connecting computers to each other? Well, that's when we step into the much bigger world of networks. At its heart, a network is actually a really simple idea. It's just a system that connects computers so they can talk and share things. It could be as small as 2 computers in your office sharing one printer, or as gigantic and mind-bogglingly complex as the biggest network of them all, the internet.
We usually talk about networks based on how big they are. You've got a LAN, a local area network. That's probably what you have at home or in your office. Scale that up and you get a MAN, a metropolitan area network, which could cover a whole city. And then you have the big one, a WAN, a wide area network, which can connect computers across a country or even the entire planet.
Okay, so we've got the physical box, the ports to plug things in, and the networks to connect them. But all of that, it's just a bunch of fancy, silent hardware. It needs instructions. It's time to talk about the ghost in the machine, software.
Yeah, I mean, what's the thing that actually gives the orders? What tells the processor what to calculate, or the screen what picture to show? Well, the answer is software. It's the set of instructions that translates our human wants into a language the machine can actually understand and execute.
So you can basically think of software in 2 big categories. First, you have system software. This is the bedrock, the foundation that manages all the computer's basic, behind-the-scenes operations. Then, running on top of that foundation, you have application software. These are the tools you actually use to get stuff done, like writing an email or playing a game.
So let's dig into that digital toolkit a little more, and we'll start with the most important part, the system software that's running everything from behind the curtain.
Let's start with the absolute most critical piece of system software there is, the operating system, or OS for short. This is the big boss, the master program that runs the entire show. It's the very first thing that wakes up when you turn your computer on, and the last thing to go to sleep when you shut it down.
The OS is basically the computer's traffic cop. It's in charge of everything. It It decides where your files get stored, it manages how memory is used, it tells the processor what to work on next, and, most importantly, it's the bridge between all the physical hardware and all your application software. You know all the big names, Windows, Mac OS, and on your phone, Android or iOS.
Okay, so once that foundational OS is running, we get to the fun stuff, the applications. These are the programs you choose to run to do specific things. Let's be honest, they're the whole reason we even bother using computers.
This is all the stuff you know and use. Word processors like Microsoft Word, spreadsheets, web browsers, your favorite games, it's all application software. And here's a fun little tidbit for you. Even nasty stuff like computer viruses are considered application software. Why? Because they're also just a program designed to perform a specific task. It's just a task you definitely don't want it to do.
This slide really just ties it all together beautifully. Look, at the very bottom, you have the physical hardware, the chips and wires. Sitting right on top of that, managing it all, is the operating system. Your applications, the stuff you use, run on top of the OS. And then finally, at the very top, is you, the user, interacting with those apps.
And that brings us right back to the beginning, to that crazy-looking ad. Now, yeah, there are probably still some terms in there we didn't cover today, but it should feel a whole lot less like a foreign language. You know that USB ports means those smart plug-and-play connections. And you know that all this powerful hardware is nothing without the system and application software that brings it to life. You now have the keys to start decoding this stuff for yourself.
So, that's our tour. But I want to leave you with a final thought to chew on. As our devices get smarter and smarter, the line between what is hardware and what is software just keeps getting blurrier. So what do you think is the next big leap forward for our devices? How will these two sides of the same coin merge even more? Thanks so much for joining me.